I was speaking
Hello.
on mute. No, I haven't logged into LMS.
Why?
Sorry?
Oh, you tried to you have an account onto that?
No, I'm not aware of that.
Please go and create the account pravatech.com. Okay. Let me
Okay.
just so please create an account. Once your account is created, write to us so we can um, assign you the courses from there itself. Okay. Bindu, I believe you have the account, right?
Yes, I have.
Okay, so it will get updated to all the video by there itself. Thank you. So guys, before starting a new topic, let's have a quick revision what we have discussed yesterday. So we talk about Hadoop uh, and its component. We talk about Hadoop component as JPS MapReduce and then 2.x we have a yarn. We had a discussion more about yesterday about SDFS architecture, how exactly Hadoop store the data, how it process, what are the use case, troubleshooting. Okay, so we had our SDFS had the three component, name node, data node, secondary name node. We talk about SDFS architecture. The first part was physical split. If you are storing the data, how exactly the Hadoop will store the data. First part is physical data will split into the blocks and it will get distributed onto multiple number of data nodes. Okay. Second is what? Fault tolerance. So the fault tolerance is all the part where we make the backup of the blocks. And so we have a replication factor. Replication factor is 3. So every block will copy 3 times on 3 different data node. The location will be decided by the name node. We discuss also about if the location, how to maintain the replication factor, right? And so every time if any node get down, all the blocks will shift on the other data node. So if this impact, name node has to update its metadata. So we learn how name node maintains the metadata. There's a communication between name node and data node. From there itself, they communicate and work on this. And there's a communication in two parts: heartbeat and block report. So 3-second heartbeat and block report is 10th. Okay. Then we talk about the two cases: over replication and under replication, right? So yes, guys, over replication. Anyone? What is over replication? Okay, over replication is the case when the partial failure had happened. Whenever in a node down, when node is not down, this happen. So signal not reached, but name node declared it. After that, sometimes the signal reached. So let's say that yeah, you can communicate. So this is the over replication. Solution is what? We have to delete the extra blocks. Under replication, we talk about whenever lack of data nodes. We discuss what. So solution is add a new nodes. We talk about the batch processing. So why the Hadoop is much faster? Because the job is running on a multiple machine and it give you the parallel processing. So it is much faster than, and it's a master slave architecture. All right. So let's talk about, so this is the three things we discuss: physical spread, fault tolerance, and the batch processing. Right. Now, if we talk about, you might be thinking, okay, if you're using 110 nodes machine, so how many machines it will be expensive. The good thing about Hadoop, it support the low configuration machine as well. You got it? Low configuration machine, meaning means a machine with 2 GB RAM. All right, it will work. High scalability, it's a horizontal scalability. You can keep adding the new node in the cluster whenever, if let's say you have 110 machine. All right, if you want to increase, you can increase. So this is called what? Horizontal scalability. Okay. The maximum number of nodes you can add in a cluster in 2.x is what? 4,000. You can write down. It's what? 4,000 nodes you can add in that cluster at a time. Maximum. No data loss because we have a good backup. Replication factor is there. Today we'll learn about limitation of HDFS. Okay, so what is the limitation of HDFS? So there's a two limitation. It work on warm principle, write once, read multiple. Write once, read multiple means data once written you cannot modify. So let's say Rishi, I've taken your data. Okay, I've taken your all the data, right?
Yep.
And your name, mail ID, mobile number, and all the thing I have stored it on SDFS. Okay. Later you come and say that my number has been changed, which is very much expected, right? Address changed.
Mhm.
So what happened when I go to HDFS and updating your record? It will say no, not possible because this principle it work. Write once, read multiple. You can read multiple times, but you cannot update. Now what to do? So you have to create another record. So whenever this case will happen, you have to create another record. So this is the challenge. Okay. So remember that in SDFS, if you're storing the data, you cannot make any changes. Either you delete or you create another file. Okay.
So we have to update the complete data itself. So if we have created an HDFS file, we need to delete it and we can add the new file.
Right. Delete. I don't think so in the production you're allowed to delete anything. You can delete it, but in SDF and client and production, you're not allowed to make any changes or you're not allowed to delete
Yeah.
any file.
When you do batch processing, either you do full load or incremental load. The full load again, you have to. I think
Incremental
HDFS.
load is also, yeah, incremental load is also there.
Mhm.
So that also depends. So by the using the scoop, we do the incremental. Yep. But
Okay.
again, uh, incremental will add, and you will get the other clarity. What do you mean by an incremental? Just when we talk about the another limitation.
Mhm.
Okay. So warm means the data which you have written you cannot modify. That one thing is very much clear. Okay. So that is the reason it does not support real time. It's good for batch processing only. We do the batch processing for what? Where the change is not required, right? Your historical data, entire transaction detail. These are the data we need to do processing where the update not required. So it's good for batch processing. Hadoop does not support real time, remember. Okay. The second thing, let's say this is the number, mobile number, and letter I want to change. So I have to create another file and I have to put it. So what is the solution? It, this because in project we need the both real time and batch processing. So they come up with a new database that is called HBase. Okay, so HBase is a new database. It's external database of Hadoop. So you have to just understand, okay, right, when you have to use HDFS and HBase. So HBase is a external database of Hadoop. Okay, and remember that HBase only work with Hadoop. Okay, so HBase can help you to make the changes. We have a complete topic we'll learn about HBase as well. The second limitation is that high latency means you cannot read or write data randomly. The meaning, you cannot read or write data randomly. Meaning is, let's say in this session we have 10 students, right? Let's say we have a 10 student, or let's say 5 student. Okay, all right, we have a 5 students. So I store, I take a new mobile number detail, all this, and I store this file into HDFS by the given name weekend batch. All right, what? A weekend batch. Okay, that's fine. What next? What next? So 1, 2, 3, 4, 5. That is what we can batch that we have written. All right, what next? So later in this batch, one more student join. What is written? You cannot read or write data randomly. Let's talk about what do you mean by write data randomly. So in this batch, one more student join. So what I will do, I will append a new record, right? I will append a new record. Again, it will not allow you. Means data once stored, you cannot make any changes. Even you cannot append any record. So you have to create another file. You cannot write data randomly. So one thing is clear, data once stored in SJFS, you cannot do any changes, you cannot append any record in that file. All right. Okay. So here what we have is the write data randomly. So you have incremental data you can add in this file, but not in the same file, in a new file. Got it, Rishikesh? So if any incremental new data is coming, so you can add it, but not in the same file, in the new file. Okay. All right. What is the no read? What do you mean by no read? Let's say you have a 10,000 record. Okay. You have 10,000 record. Let's say you have in a bank table database, we have a 10,000 record. So you generally visit the bank, right? And you say, I want the bank account detail. So the person asks you, give me your unique ID. Unique ID is what? Your account number. So you say that, let's say your account number is this, right? Let's say 785. So when they type in the search box 785 in RDBMS, let's say if they do in Oracle, so this all the record is what? Indexed. Index, what is the advantage of index? It will directly jump onto this number. When it search 785, it having its own address. So it will directly jump on this number, and fraction of second it will display on the screen, right? So this is what RDBMS, how it works, because every record is indexed in Oracle in RDBMS. So that's why within second you get this all the records. So here you can read any data randomly in RDBMS easily with fast response. But what if you do the same in SDFS? SDFS what will do? It not hold any record address. It's just simple a file system. Like in a society, 100 house there, 100 building there, and there's no address. So you have to go each and every place. You have to knock the door and ask, is this your parcel? Because there's no address. This is the same problem with HDFS. It hold all the files, but it does not hold any address for that. It's simple file system kind of. So it will scan top to bottom. You got it? It will scan top to bottom. Of course, it will take time. So that is the reason it is called high latency. It takes more time. So this kind of job is not recommended to perform on HDFS. It will impact the performance. Okay, so what next? The solution is HBase. HBase can give what all the limitation in Hadoop HDFS is a solution. You can update the record, you can append the record, you can read or write data randomly as well. Hope it's clear. Yeah. All right. So the point. So Hadoop is mainly designed for the big data. If you have the huge amount of data, then go for Hadoop, or else if not, then you can use the tool, the database you're using. Okay. Hadoop support the Linux interface. In fact, it can work on Windows, but in production we only use a Linux interface. Okay. In fact, in the Linux only production works on CentOS and Red Hat. So remember, this is very tricky. Anytime you find an interview, find out the learner, they ask which operating system you're using. They said the Ubuntu or Solar or some Mac. It won't possible. But production work only on CentOS on Red Hat. Remember. So this is what we have. What is the flexibility? It support commodity hardware, low configuration machine. Okay, so low configuration machine. It's a commodity hardware. It's a low configuration machine where we can support 2 GB RAM, 4 GB RAM as well. Okay, so this is all about the architect and its limitation. Okay, let's talk about next part, metadata. What do you understand by metadata is? Yes.
Metadata is data of data. So how the data is stored, what are the attributes, what type of attributes?
Which data?
The data that is stored.
Okay, so metadata, it hold the information which data already stored on your node, right? So it's a data of data, all right? Okay, but what exactly you understand? What if we explore the metadata? What kind of metadata? Where is the transaction information? Where is the location of the address? If any file get deleted, where is all the information? Like yesterday we talked about data dictionary in RDBMS, all right? So RDBMS does not hold any past history, remember. So your number is okay, your mobile number is this, and if you make the changes, right, it will update the record, but it will not hold this record in the same table, remember, in RDBMS. So there's another table which maintain all this past record. So from that table, if they ask you the transaction detail or any past record, from there you actually will get this. It will show only the updated record. So you go and check that what is your latest balance, current balance. So it will take from this table. What was the previous balance, settlement and all the things, what you have, the history of this. So it will go and check into another table, transaction data dictionary. All right. So here is a metadata. Metadata is on the disk. Okay. So this is the name node. Okay, name node. Sorry, it's name node. So name node maintains the metadata. There are different type of metadata actually. Okay, there are type of metadata, and name node holds this metadata in two different directory. Okay, name node holds this metadata on two different directory. Okay, so type of metadata, and name node holds this different type of metadata, two different directory. One is fs image and the second is what, edit log. Okay, one is fs image and second is what, edit log. So what is edit log and fs image? Fs image is nothing, it's a file system, snapshot. Okay, both the directory, both holds. So what fs image information hold? So fs image is okay. Let's say you create an account. So Bindu, In your company, in your team, you have a team, right? You might be have a team lead, manager. Hierarchy must be there. Someone will be working under you. You will be working under them. So how you check this on the hierarchy? Who is having what kind of authentication for that particular project? Yeah, where the system. Hello, where is she? How you
Sorry,
check all this flow?
can you please repeat the question?
I mean, in your project, in your company, you will be having a team, right? Someone working under you. You will be working
Hmm.
some under them, right? So
Hmm.
who is having the what authentication? Okay, in that project, right? So to check this hierarchy, how you check all this? Is there any tool?
There are multiple tools that we have. In our organization supports an org chart, so there is a tool that they use. The second tool is also like mind map tool that you use to create the
Mm-hmm,
hierarchy and view it,
mm-hmm.
or they store it in corporate database where they have all the hierarchy of the organization.
Okay, all right. So, okay, thank you. So one thing, while having tools access this information, right? The same way if we talk in Hadoop, right? The same way if we talk into Hadoop, let's say, right? You store a one file, okay? So is the owner of the file, right? In you are maintaining this. Under you, you make a team dev, team admin, testing, right? All this you are making. Sure, Bindu. So, okay. Where's that? Where's that? Okay. So you are the owner. You store one file in HDFS and you're maintaining. Under this, you have a dev admin testing team. Under the dev, you might be have two people, person working. And this admin, you have this two people person. In testing, you have some four-person kind of, right? Now, you might be checking who is having what authentication. All right, that's very important, right? So all this thing you can come and check it into your FS image, that is snapshot. It hold all this information which you have in that. Okay, now what edit log holds? What edit log hold? Once the file created and stored, once the file created and that file deleted, what all the transaction it happened? File creation to file deletion. What all the transaction it happened? You read the file, you run the job, all right? You make the changes, change the block size, anything related to that file. What are the transition that happen? It will hold on your edit log. Edit log, or it is also called transition log. Okay. So this is the to info that it hold on your metadata, and it give you all the information. So according, this is how they organized, and according to your requirement, you can go and take the data from there. So okay, okay. The interesting point, what exactly? Name node. Let's say, okay. I talk about when we talk about the cluster, right? When we talk about the cluster, so we have a 5 node cluster, like one name node, 4 data node, right? It is having. So name node hold the metadata on its own database, on its own metadata. Okay. The machine where they're running. Let's say you are you are let's say my machine is name node, Bindu your machine is one data node, Rishi your machine is another data node. All right. Let's say we have a 3 node cluster. So when we store the data, name node holds the metadata. So name node will hold the metadata on the same disk where the name node is running. So my machine is name node. So on my disk, when we configure the cluster, we set the path. Okay. So will name node will set the path for the metadata where you want to store this. So on my laptop, let's say D drive. Okay, I will define the path. So whenever whatever the metadata is generating, it will store into the disk. But the point is, when you start the cluster, name node will pull all this metadata from the disk and it will put into the RAM. The reason is very simple. Anything on the disk or RAM, which is faster? Of course, RAM. So why name node putting all the data from disk to RAM? Because in a cluster, when a single process, any single operation without name node won't possible. Either you want to read or write anything related to the data, you should know the location of the data first. So that location is maintained by the name node in metadata. It's just like a reception I told. So any information you want to gather first, you have to go through this. Then it will give you the location and then you can access. So it is very much clear. Yes, if it need this info, then why we put on disk? Let's put onto the RAM. So it give you the much faster result. It should not waste. It should not wait. Okay, data on the disk again. It will process again. It will take time, and so everyone is coming. So let's put the data onto the RAM. So that is the reason name node is what called memory hunger. What is called memory hunger? The memory hunger is all about what? Right. The more means, and we have a 3 node machine. So which machine you should make the name node? Machine which having the higher RAM configuration. I will recommend make that machine name node. Why? Because this reason name node utilize its RAM to put all the metadata. Clear? All right. So it happened. Name node move the data from disk to RAM whenever you start the cluster. Remember. Clear? Now let's talk something more about name node metadata. Um, so Rishi, you have the software ready on your machine, right? Right.
Yeah.
And Bindu,
Yes.
you have the software on your machine. Can you start your cluster, please? VM, just one sec. Okay, so uh, yes, Rishi, you had the setup.
Yep.
We'll talk about this.
Yeah, it's ready.
So what happened when you start your machine, right? What all the data, whatever the metadata it has, it will put on a RAM. That's what I will say. Okay, this is whenever you restart the cluster. So there's one more level. Name node put itself in a safe mode when you start the cluster. Okay, name node put itself in a safe mode when you start the cluster. How and what is a safe mode meaning? So it's just like when you start your RAM laptop, your machine, any software based, it takes some time. That is called booting. In that time, your operating system, your other files get uploaded onto the RAM. Alright, till that you're not allowed to operate your machine. So from there itself, it take time, and once this file all uploaded, then you're ready to operate. So how fast depends upon your machine configuration, right? The same way, name node will put itself in a safe mode. This booting technically means logically you can say safe mode. Means name node in safe mode means when you start the machine, you see all the files are getting uploaded. Still, it is not running. You see that it is still taking time. You see here. Still, I'm not ready to run this. So now in this period, name node is what in safe mode, meaning all the files, other libraries, operating this cluster data, everything is getting uploaded. Meanwhile, one more, this also data from the disk to RAM. This is also getting uploaded. You see here, it's getting. So how fast it will do, it depends upon your machine and my machine configuration. All right. So when the name node in the safe mode, SDFS will be in the ROM mode, read only mode. You can go and read it, but you cannot do any prop job. You see here, and open the terminal. You see itself, it's taking time. You write 0 JPS. You see, it's taking time, right? It's getting uploaded. You see, now it's some of the processor you see there. This is still processing. So it is taking time, which showing it's running under that. Okay, because of this. Once all the file, everything is uploaded, this entire disk, right? This entire disk, uh, right? This entire disk, you will file get loaded onto RAM, right? So uh, it will come out from the safe mode. So now after come out from safe mode, name node will SDF will become active. We can do as per requirement. But what happens sometime? Name node could not come out from the safe mode. Okay, name node would not come out from the safe mode sometimes. So when you run the job, you will get an exception, a name node safe mode exception. Got it? What you'll get it? You will get an exception, name node safe mode exception, because name node should come out from the safe mode, but it could not happen. So manually you have to take out the name node from the safe mode exception. This is the command. Please write down. So you have to run this command, sudo hyphen usdfs sdfs dfs admin hyphen set mode leave. Okay. Hope you're writing. Let me just
Done.
yeah, ping in the chat window this command. Okay. So this is the same to sometimes for the maintenance you can put the name node in the safe mode as well and write it get. So name node will come in the safe mode. For the maintenance part is all we can do it. All right. Okay. You can write down some questions. I'll assign you some question. So you can do it. Yep. The model one. Hello. Yeah, you there? Bindu? Yeah, please write on these questions. Yeah. So you have to next week and before starting, you have to answer. So that will give you more clarity. The conditions which required, what is the condition? So name node decide which block should store on which node, right? So what is the algo? How would this algo work? Okay. Which function split the data to convert into the block? So how to modify the heartbeat? Remember the heartbeat is what? 3 seconds. If I want to make changes in the heartbeat, okay, how to do that? All right. What if fs image and what type of metadata it stores just now we discussed. So explore more, explore more. If we have a 2 TB of data, and what is the maximum expected metadata it will generate? Means what the storage it will take for the metadata or name node. Okay. How secondary of this we have not discussed. How secondary to make the backup. But what metadata that hold in the cache memory? So if any data node stop working, how the blocks of dead data node will move to the active data node. Write the condition in which case the block size changed. So if you're making the block size 128, later you are making some other changes. So what are the different cases? And we make the block changes. So again, just let me type this in the chat window. Did you get that? Hello?
Yep, got it.
Okay. So very important. Let me do some practical. This command you should know. You see that now you're ready to start. So I will clear. So let me store a one. Let me show you how to store a one file on SDFS. This is the one file. So I'm moving from local machine LFS. So Linux interface, guys. Hadoop FS. This is all the concept. You see here. Right. This is all the commands are. On cat to read the file. So I believe you have a fair understanding of Linux. Bindu? Yep. Rishi.
Yep.
So you can see all this command. Can you start your machine, please? A VM.
Yeah, it started.
Okay, just go to that. AVM is there. So you can write on the commands, please. So this is the command to store the data in SDFS. Please write them. Hadoop FS. So if you want to store any file, let me show you. If you want to store any file that Hadoop FS happen put, and there we have the files. This happen put on Cloud desktop. EVM where you want to store, so local machine path and where you want to store in SDFS. User Cloudera. EVM is already there, so I will rename the file. Today is 21st, so 21st June. So the file stored. If I want to read the file, cat user Cloudera, get the file name 21st June. Okay. Uh, I'm making a presenter. Bindu, you have the software ready with you? I'm making a presenter, Ishi. Can you share the screen, please?
Can you see my screen?
Yeah, that's fine.
Yeah.
So create a one file on desktop first.
File desktop.
Get the file name, anything.
Any data?
Hmm?
What data should we add over here?
Anything you can write in, no problem.
Okay. Let's keep it simple.
Mhm. And text word line was
So user we have to use Cloudera or
sorry.
where we need to put?
Okay, just write it. Just one sec. Not user. Yeah, Cloudera. No. Okay. CLOUDER. Yeah. Yeah, done. Now Hadoop fs hyphen cat and get the file name to read the file.
Only the file name or complete
The
path?
path with path, of course. Path here. Yeah.
Yeah.
It's coming right. You can
Yeah,
open the
display.
UI. Yeah, you can open the UI. Open the browser.
Mm-hmm.
You can check it from. No. Not this. Okay. Okay. Go to the SDFS name node tab. Yeah. On top. On top. No. On top. Yeah. On top. On top.
I'm so sorry.
SDFS
Okay.
name node. Browse the file system. Yep. You can see the data from there itself.
Mm-hmm. Okay.
Okay. If you want to delete the file, have a hadoop fs -rm and give the file name. Try this.
trash, it moves to trash.
Yeah, it will move to the.
Okay. Anything else?
I'm just searching this one there. Okay, just let me make it. Um, okay, if you want to change the replication factor of this one, set rep. So Hadoop fs hyphen set
Set.
rep and give the replication factor value and give the file path.
The file is not there.
Oh, okay. So
Okay.
we can
That's okay.
edit it, then make the changes in that. Right,
Okay.
it's done. You can check that. Okay.
Yeah.
So this is how you can make the changes in the replication factor value. Okay. You can write this all the command in a one file, so that's how you can do that.
Yeah.
Yeah, Bandhu, you can do the practice all on your machine as well. So you can run a job. Okay. CD user lib Hadoop. I'll run a job. CD user USR. Yeah, there's some job. Yeah, user lib. Enter. ls user lib Hadoop 0 point Hadoop hyphen. Yeah, Hadoop hyphen. Yeah, enter. ls. Yeah, these are the jar files. So you can write on Hadoop jar.
Hyphen jar or Hadoop jar?
No, no, Hadoop jar. Simple. Hadoop example. You see that Hadoop example. Yeah, that jar. You can type in a tab to take it for me. Hyphen. Here. Write down class name word count small letter. Word count small letter. Space. Which where you want to run the jar file, on which your give the file path with the name user cloud. Okay, now you give the directory of sdfs where you want store output space user cloud and give any directory name. So this directory will create automatically. Yeah, that's it. Enter. Go and check the output.
What by what name it stores?
You created output directory. That is a directory. Refresh it. Inside there's a one file. Yeah. So part
Part.
triple yeah. This is the file path. So you can give the complete path to check the output from terminal.
So, so how to list the files inside the directory?
ls.
ls.
This will Hadoop fs -ls. All the same command of Linux. Just I given you the.
Look,
You just write Hadoop fs and you can get all this. Yeah. You can.
look,
Done.
yeah.
All right. Yes, Bindu. Any questions you have? Yeah, I guess you have this Hadoop software with you, Bindu. On the website as well, our website, providec.in, you go to the services, and onto that, there's a Hadoop software. So you can take it from there itself. All right.